we're going to look at the same problem again. Okay, so now what we're going to do is we are going to determine, okay, we are going to determine the first or the Q Z of point B. Okay, QZ of point B. So if we don't use the positive and negative first moment of area, you have to obey the rules that I have developed. Okay. So we know that this distance from here is 35 millimeters. And if you apply the rules that I've developed, it states that the first moment of area cannot cross the geometric centroid. Okay. And the analysis, right, goes in this direction. So the first moment of area at point B is this area. Okay, the analysis starts from the furthest distance, start from y max. Okay, so over here, this is our y max, and then it goes inside because this is in fact also our small y, right? Okay, if we look at the analysis starts from y max. So when that's the case, then we have to also then we can calculate our what our first moment of area. Okay, so we're going to use this technique. So we know that the distance from here to here is 65. Okay, so we know that QZ at point B now. Okay, now we have to take 2 because we have left and right web. So the formula, let me write out the formula, is Y depth Y bar, right? So the width over here is 20. The width is twice because you have left and right web multiplied by 20. Now the depth is given to us, which is straightforward, 30. So now if you have problem doing the Y bar, right, you just apply the formula, right, which is equal to C plus by Y multiplied by half. C is the furthest distance away from the centroid, which is equal to 65. Plus by the what? Plus by the y. Now y you have to be careful, right? So this is equal to 35. Plus by 35 multiplied by half. Or, right? Or you can also do 2 multiplied by 20 multiplied by 30, which is the depth. And then y bar, you know, is equal to 35 plus by what? You know that's 35 plus by 15. Okay, by observation. Okay, so the answer should be the same. So this is equal to 65 plus by 35 times by 0.5 times by 30 times by 20 times by 2 is equal to 60,000 millimeter cube. Okay, let me do it. 2 times by 20 times by 30 times by 65 plus by 35 times by 0.5. Yep. Or, right, 35 plus by 15 times by 30 times by 20 times by 2, also the same. Okay, but when you use your first moment of area has to be in meters, so it's 60 times 10 to the power minus 6 meter cube. Okay, this is also 60 times 10 to the power minus 6 cube. Okay, now the next thing that we are going, so this is by using the rules that I've said, i.e. the analysis starts from the furthest distance away and then it go inwards. Now, what if now, right, you want to do something different? Okay, what if now, okay, you want to use the positive and negative area? You could, but it'll take you a bit of time. We have time. Okay, I'm going to show you both methods, and if both methods should get you the same answer. Okay, so how about do we do this? So now we know that our our geometric center is here. Okay. And then the distance from here to here is 35. So now the area that we want to take is we're going to take this entire area. Okay. And we can do that. There's nothing wrong with that. It will just take a bit longer. Okay, that's it. But the answer has to be the same. Okay, the answer. So the next one, we are going to use positive and negative Q. Right? We're going to do the positive and negative Q. Okay. So now we don't need to follow rule number 4. The first move of area cannot cross the centroid. Okay, it can cross, but whatever on top is our Q positive. Okay, whatever at the bottom is our Q negative. Okay, so we are going to calculate the Q positive for the flange. Okay, so the width is 160. The depth is 20. The Y bar will be equal to what? 35 plus by 20 multiplied by half. Okay, so we have this already, right? So 160 times by 20 times by 35 plus by 20 close bracket times by 0.5 is equal wait, 35 plus by 20, is it 35? Yeah, 35. Oh, no, not plus by 20. That's where I got it wrong, because the distance from here to here is 15. Y is 15. I do apologize. So 35 plus by 15 times by 0.5 times by 20 times by 160 is equal to 80,000 again. Okay, millimeter cube. Then we have the Q positive for the web. Okay, so 2, and then the width is 20. The depth is 15. The Y bar is 15 divided by 2. Right? So 2 times by 20 times by 15 times by 15 divided by 2 is equal to 4,500 millimeter cube. Let me do it again. 2 times by 20 times by 15 times by 15 divided by 2. Yep. Then we have the Q negative for the web. Okay. So left and right. Thickness is 20. The Y is 65 minus by 30, right? We know that the distance from here to here is 35. Multiply by 35. Multiply by 35 divided by 2. Okay. So 2 times by 20 times by 35 times by 35 divided by 2 is equal to 24,500 millimeter cube. So the outcome, the Q, okay, the Q Z for point B will be equal to absolute value 80,000 plus by 4,500 minus by 24,500. Okay, and all these are its absolute value. So it's equal to 80, 123 plus by 4,500 minus 24,500 is equal to 60,000. And this is equal to 60 times 10 to the power minus 6 meter cube. Okay, so you can see that whichever technique you use, this is using positive, negative. Okay, this is using all the rules that we have applied. The answer is the same, but you can see over here, the working is so short, right? Over here, you can make mistake. In fact, I make mistake on the first round already. Then you have to consider this. The more components you have, the more mistake you will make. Okay, but again, it's entirely up to you. Okay, there like for this case, if I'm going to find B, I'm going to take this area. It's so much more easier. Yes or no? And then if I'm going to find, if I'm going to do A, it's so much easier just by considering just the top. Okay. So you have to comply to the rules. But if you want your first moment of area to cross over the centroid, okay, to determine your point, you can do that also. All you need to know is what is a positive. You determine what you want to call a positive moment, okay, and what is a negative first moment of area. Are we clear? Okay. Right. So I want you all to be the thing about most complex regarding what we are doing down here is the first moment of area. Okay, the first moment of area is always the most difficult. Okay. I'm going to I'm going to do the same problem. Okay. And again, for the past 45 minutes, I've been focusing on first moment of area. Now we are going to derive. Okay, we are going to derive the expression, or we're going to derive the shear force equation. Sorry, the shear stress equation. I repeat again, we are now going to derive the shear stress equation. Okay, and I'm going to show you how powerful. So what if we derive the shear stress equation? So what? Okay, so we are now going to focus on solving this problem now. Okay, let me. Okay. Okay. So I'm not going to bother to look for the first or second moment of area. So I'm going to write over here given. Okay, given, because all of you, I believe, know how to find second moment of area, and I don't want to do it again. Okay. So given, also given that IZZ is equal to 5.813 times 10 to the power minus 6 meter 4. Okay. So for the beam and loading shown, consider NN and determine the shear stresses at point A and point B. I'm going to do something further. Okay. Part C, we are going to derive the shear stress distribution equation. Okay. And E, the resistance, not E, what am I doing? And D, the resistance force for the flange and web. Okay, so that is what we are going to deal with. Okay, so now